So here's the third and final video or theory-based video on Le Chatelier's principle. Now, just a reminder, Le Chatelier's principle states that when a system at equilibrium is exposed to a change, it is going to shift in a direction which will partially oppose that change. So as we said before, if you increase reactance, it's going to shift to try and decrease those reactants and move forwards. If you decrease reactance, it's going to shift and try and recreate those by moving backwards. If you increase the temperature, it's going to favor the endothermic reaction to cool it down again. And likewise, if you decrease the temperature, it's going to favor the exothermic to increase the temperature again. So the idea of this is all about the partial opposition to a change. We do this to try and maximize yield and get more cash in our equilibrium systems. So the change that we're going to study now is decreasing volume of a system. Now, by decreasing volume, what you're going to do is you're going to increase the pressure or increase the concentration of aqueous solutions. So that's what we're going to look at in terms of our change. So by decreasing the volume, what happens? We have an increase in the concentration or pressure of a system, and a sharp increase at that. Now, what does that cause according to Le Chatelier's principle? Well, if you increase the concentration or pressure of an entire system, this system is going to try and oppose that by reducing pressure/concentration. To do this, it's going to favor a side with less particles, because less particles means less pressure. So therefore, by decreasing the volume, you are increasing pressure/concentration. The system's going to oppose that by favoring the side with fewer particles. That could be the Ford's reaction, it could be the reverse reaction. It depends on what reaction you're looking at. Now, in a similar way to our last two videos, let's talk about this in reference to collision theory. What happens to the rates of reaction to cause this change to happen? Well, first of all, let's look at my graph here of my forwards and backwards reaction, and let's see what a decrease in volume does. Instantaneously, you can see a decrease in volume fires up both the forwards and reverse reaction because you're increasing the pressure or concentration of all particles. So both reactions spike. The difference is one of them is going to spike more, and that's the direction that's favored. So the direction with less particles is going to be spiking more than the other one. Why does this work with reference to collision theory? Well, let me read what it's got here. An increase in the concentration increases the frequency of all collisions, we understand that. The side with more particles, the concentrations increase more, so those are going to collide more often, and that means they're going to react and push the direction to the side with less particles.